Hi, my name is Richard Scannell. I'm the CEO of a software company called Lambent. Uh, every construction project I've been involved in has come in late, and I always thought it was the builder's fault, but I'm starting to wonder about this architectural thing a little bit. I am an outsider. I know next to nothing about architecture. The only thing I know is we redid a house, and we had a designer who told us you cannot have a bathroom where the first thing you see when you walk in the door is the toilet. And guess what I have? So we are a rebel as well as everything else. Lambent is a product that's really focused, unlike everything else that I've heard about since I've been here, which is really all state of the art stuff. I mean, 99% of it over my head. Lambent is focused on the environments that exist. And in our clients, the vast majority of them are overbuilt. So what we're trying to do is help them understand, what do people do with the spaces that you already have? So we're not here to help you build new spaces. We're absolutely here to help you understand, what are you doing with what you already have? The product is launched just over 2 years ago. We're based out of the Boston area. And you can see some of our customers, some prestigious universities and large corporate customers. And we both go to market directly and through a bunch of partners. We are what somebody described as a startup, which is a fancy VC word for we lose money, but we're working on it. The data that we deliver is regarded kind of as becoming regarded as poker stakes to some degree in the facilities organizations that we sell to. So if you went back 20 years ago, in your average large corporate environment, space was tied to headcount. The HR team would put out a report every year saying we're going to hire 400 people, and if you were a grade 9, you got a 10 by 10 office, and if you were a grade 10, you got a 20 by 15, and so on and so forth. I worked for Motorola at the start of my career for 10 years. And the depth of the carpet, I knew when I walked into somebody's office what grade they were, because the degree of padding that they got dictated whether they were a director or a senior director or a vice president, the quality of the furniture. It was incredibly structured. We don't need to talk about COVID and Zoom and what all those things have done to the existing environment. But let me say that if you have a child in college, and I have one who has long since graduated, call them up and tell them you want half your money back, because the degree of over-constructed capacity in the average university that we're seeing is extraordinary. And there is almost no data to help people understand that. And that's where we come in. We help people to understand how their spaces are used. We help them to understand how their spaces are not used, and we help them to understand how people move through those spaces. And we do that with a very common and pretty simple mechanism, which is we use Wi-Fi data, which is pretty ubiquitous. If you look over your shoulder, right under the camera up there, there's a little white box. It's called a wireless access point. If you happen to be connected to the network in this building, it's very likely you're connected to that wireless access point. That access point is collecting a bunch of metadata that says, here's when you connected. If you got up and left, you disappear and you show up in another access point, and so on and so forth. We can get all of that data completely anonymized, so we can't track individuals. And we push that all through a series of AI models, hence probably why I was asked to speak, because we use AI. And those models analyze the behavior of every device on the network. And essentially what we're trying to do is figure out, is this a person? And you can essentially score each device as the time goes on with confidence as to whether or not it represents a person. And once you have a reasonable degree of confidence that it represents a person, you can then essentially plot it on a map or on a picture of a building. The beauty of that data source is it scales out incredibly quickly. So we can scale out to millions of square feet in days if you talk about the building and floor level. If you want to break down into more granular spaces, we go down to what we call zones. So a zone is an area of one or multiple access points. So this room would be a zone. That takes a little bit longer, mostly to actually just get the renderings from the client and break it down. Zones are very context sensitive. So we may look at a building and say, well, that's a zone and that's a zone. Well, it turns out that's the marketing department, and that's kind of half marketing and half sales. And, so those contexts are very, very important. But the scale out is very rapid. There are other approaches to do this, of course. And I'm guessing in the architecture world, you're probably already working with a bajillion different sensors. And so they're not even that old, that new, right? Sensors have been around for a while. The problem is, if you talk about the very large amount of real estate that already exists, we worked with a bank in the Boston area, and to put sensors through one of their buildings before they bought a sensor was going to be $2 million, because they had to pay electrical unions to pull the cables, and they had to pay carpenters unions to stick them on the walls. And if the first thing that they're going to figure out is, shit, we don't need this building anymore because there's nobody who comes into it, it's kind of an upside down paradigm. And so we can get people to, a pretty actionable amount of data very rapidly, and then allow you to drill in. So if you just start at the building and floor, and then you work down into these zones. And then if you want to go further, we're out. We tap out at a certain level of granularity. We're just not that good. So we don't believe sensors are really a competitor. We think they're just a fit for purpose scenario that's different from ours. Historically, what people did was they hired people to walk around with clickers and clipboards. And it's a bit like going to the doctor and say, am I going to live for another 10 years? And they say, well, how did you feel last Tuesday at 10 o'clock, right? It's a point in time, completely irrelevant, doesn't really indicate anything as to the use of the space. You can look at seasonal impacts. You can look at, the movement of people. We have a university right now. One of the things we're really struggling to understand is when people leave one of the large buildings that's very active, 80% of them who leave that building go to a different building the entire way across the campus that seems to have no bearing on the building that they're leaving. And so we're working with our customer to try to understand why on earth does everybody go there. But the data that comes out of this very high level set of analysis it generates a lot of questions very quickly. In terms of how it works, as I said, we score each device. What you're seeing here is essentially just a graph that shows when we turn on the data first, the AI engine sees every device as a person. And then after a couple of days, it begins to realize, well, that device didn't move. It didn't go home in the evening. It didn't, so things that look like human behaviors. Without getting into it, we do take account for people who might have two devices. We take account for people who might be walking past and connect for 10 seconds and then drop off and things of that nature. But this is not a science insofar as we don't get you to 100% accuracy. Sensors can get you to in the high 90s. That is not what this is about. This is about helping you to understand at rough orders of magnitude, which we would say is about 90% accurate, what's going on in a building. And if I tell you that there's 50 people going into a building that can accommodate 500, doesn't really matter if I'm off by plus or minus 10, right? The decisions you're going to make to keep, heat, cool, clean, bring services into that building are largely going to be the same with a standard deviation of, plus or minus 10%. Again, even with our platform, there's kind of this fit for purpose granularity. So we have simply an API that we support partners with. And we have partners who have use cases where they simply want to take certain amounts of data from the platform and expose that to their customers. So some of the IWMS type platforms, if we're familiar with any of those. And then we have at the bottom right, we have a kind of a floor level. So you can see, there's 10 people on the floor, 50, 30, whatever the number is. And then on the upper right, you're seeing kind of zones. So again, depending on what granularity you want to get to, it scales out very rapidly. And I will win the prize for brevity today. So the last slide, essentially kind of where does this go from here? So we apply AI to Wi-Fi metadata to derive occupancy estimates and some other things about people and how they move through space. The next wave will be to apply AI to that derived data. So today, if you have a question about a space, hopefully we can answer that question of what's the least used building in the campus? What's the building where most people go after they leave this or the building? What is coming is, tell me an answer to a question I didn't realize I had. And that's another big data problem, right? So if you have 10 or 20 million square feet on a large converged campus, whether that's a commercial or a higher education institution, are you asking the right questions? And what things can we uncover that we can offer up? And in very, very rudimentary analysis of this, just in our data science team, we've already uncovered, if you combine the frequency of stay with the length of stay, you can very quickly find buildings where not a lot of people go, and when they go there, they don't stay very long. And if you then look at that as a series of buildings that probably are good candidates for either deferred maintenance, getting out of leases, again, we don't cast judgment on what you should do with these spaces. We're simply giving you a tape measure to say this is a foot and this is an inch. but you can very, very rapidly get to, highly actionable targets for consolidation, optimization, and so on. So that's us. Happy to answer questions after when you're ready.